Let's start with free radical substitution. In free radical substitution, let's take the simplest example of an alkane, which is methane, CH4. Now, when this undergoes free radical substitution with, for example, Cl2. Now, since alkanes are saturated, the Cl2 cannot come and bind to this methane. What, however, can happen is this one H can break off and it can be substituted by a Cl, giving monochloromethane. And then maybe another H can be removed and another Cl can come here, giving dichloromethane. And then maybe another Cl can come instead of this H, giving trichloro. And likewise, this one can also be lost, giving us tetrachloromethane. So all the H's can one by one be removed and replaced or substituted by Cl, because you can't join them otherwise. You can't add the Cl because it is an alkane which is saturated. It has 4 bonds. Can't make a 5th one, right? So whenever alkane, let's for example methane, if it undergoes free radical substitution with Cl2, it can give us 4 products. The first is CH3Cl, which is called monochloromethane. Then you can also have dichloromethane, in which 2 hydrogens are removed and 2 Cls are replaced. This is called dichloro. There is also a possibility of getting trichloromethane, and you can also get tetrachloro, where all the hydrogens are replaced by Cls. This is called tetrachloromethane. Now, how does this happen? How do you obtain these products? So with CH4 undergoing free radical substitution with Cl2, it can give 4 possible products. How does it happen? It begins with initiation. Initiation is a process by which a Cl2 molecule will break into 2 Cl radicals. And we know how. Cl will break homolytically to give us 2 Cl radicals. And this takes place in the presence of UV light. Right? So this breaks here, giving us 2 radicals by homolytic fission. Then the reaction propagates, which is called propagation. Now, propagation takes place to give us these possible products that we just listed here: monochloro, dichloro, trichloro, and tetrachloro. These can be obtained by homolytic by propagation. Now, what happens is CH4, which is methane, it reacts with a Cl radical which was formed, one of the Cl radicals which was formed in initiation. And now I'll need to explain this a little. Like, this is CH4. The bond in black, the CH bond in black, let's assume this bond needs to be broken, or this hydrogen needs to be removed. Because if you remove one hydrogen, is only possible that we can have a Cl instead of it, the hydrogen. So this bond breaks homolytically. When it breaks homolytically, we get an H radical and we get a CH3 radical. Now, this H radical is super reactive. This H radical is so reactive that as soon as it's formed, it reacts with this Cl right here to give off HCl. It does not exist independently, but it reacts almost instantly with the Cl radical to give off HCl. What we are left behind with is a CH3 radical. We still don't have monochloromethane, but we have this methyl radical now. Now, this methyl radical, CH3 radical, joins with a Cl2 molecule this Cl2 molecule will break homolytically, giving two radicals. One radical will be obtained as it is at the end, and one radical will join with this methyl radical, giving CH3Cl. And now we have monochloromethane right here. We see monochloromethane right here. Now this doesn't end here. We can further obtain dichloro, trichloro and tetrachloromethane. How do we do that? So after you get monochloromethane, this CH3Cl, monochloromethane, joins with another Cl radical. And one of the hydrogen has to be broken down now. It has to be replaced, it has to be removed. And when the hydrogen is broken off, it forms an H radical which instantly joins with this Cl radical to give HCl. And one of these three has been lost. One of the three hydrogens has been lost. So it becomes CH2Cl radical plus HCl. Now CH2Cl radical joins with the Cl2. Now this Cl2 splits homolytically to give two radicals. One radical is obtained as it is, and the other radical joins with this radical to form CH2Cl2. Now we have dichloromethane right here. After obtaining dichloromethane, we can also further obtain trichloromethane. Let's see how. Now this dichloromethane, which is CH2Cl2, joins with the Cl radical. And one of the hydrogen has to be broken off. One of these two. So it will become CHCl2 radical. And that hydrogen that is broken off joins with this Cl radical to give HCl. Now the CHCl2 radical joins with the Cl2 molecule. This Cl2 molecule breaks into two radicals. One radical is obtained as it is, and the other radical joins with this guy to give CHCl3. So now we have trichloromethane right here, CHCl3. Then you can further have propagation, where the last hydrogen that's left, that is CHCl3, reacting with the Cl radical to give CCl3 radical, and the H that is broken off or given off as a radical will instantly join with the Cl radical to give HCl. Now the CCl3 radical will join with the Cl2 molecule. This Cl2 molecule breaks into two radicals. One radical is given as it is, and the other radical joins with this guy to give CCl4, which is tetrachloromethane right here. So we have all these four products that we needed. Now this reaction ends. The second step was propagation. The reaction stops at termination. And what is termination? When any of the radicals that were formed in propagation, any of the radicals, for example, it could be this radical, it could be this methyl radical, it could be a Cl radical, it could be a CH2Cl radical, it could be a CHCl2 radical. Any of the possible radicals that were made in propagation that are highlighted in green here, when these radicals come together, any of the two radicals, for example, let's take a ClCl radical. A ClCl radical joins to give a Cl2 molecule. Or let's take two methyl radicals, a CH3CH3 radical giving C2H6, or maybe a CH3 radical with a Cl radical giving CH3Cl. This marks the end of the reaction where two radicals come together to give us a molecule. Now, if you notice a pattern here, in initiation, there is always from a molecule you are making radicals. In propagation, a molecule and a radical give a radical and a molecule. And in termination, two radicals will give a molecule, right?